Geometric progression or exponential sequence. A geometric progression or exponential sequence is a sequence where each term is obtained from the preceding term by multiplying by a constant factor. Now, this constant factor is called the common ratio and is denoted by R. Now, let's look at our first example. Is this a geometric sequence? Of course it is. This is because it has a common ratio. Now, taking a term and dividing that term by the preceding term, for example, 8 divided by 4, we get 2. Similarly, 32 divided by its preceding term, 16, we again obtain 2. And this goes on and on and on. Therefore, this is a geometrical sequence or exponential sequence. Now, taking our second example, we have our first term to be A, second term to be AR, and third term to be, of course, AR squared. The question we ask ourselves is that how can we find any term which we are asked to find, whether being the first, second, or third term? Before then, it is clear that the common ratio in each of them is R. Since taking a term and dividing by its preceding term, we obtain R. So AR divided by A, we obtain R. AR squared divided by AR, we also obtain R. Therefore, R is our common ratio. Now, the general formula for geometric progression is given by U subscript n is equal to AR to the power n minus 1. Now, this is our general equation. Now, A represents our first term, R represents our common ratio, and n is the number of terms in which we've been asked to find. Now, let's take an example. Find the 12th term of the GP 128, 64, and 32. This goes on and on and on. It's so simple to get our first term since our first term is always first. So we have A to be 128. Our common ratio, we take a term, divide by its preceding term to get our common ratio. And most students do this mistake, expecting the common ratio to be a number bigger than 1. It's not so. So we obtain our common ratio as half. And we've been asked to find the 12th term, so n is equal to 12. Now that we've gotten all our parameters, let's insert them into our equation. So we have U subscript 12 being equal to our first term 128 multiplying our common ratio half to the power 12 minus 1. Now, solving this, we get half to the power 11. One simple method of solving this is by expressing this as powers of 2, and this to the power of 2 gives us 7. And also, we can, by indices, we can bring the 2 up, and the 2 will be to the power 11. Again, since they are multiplying with a common base, we can simply add their powers together. So we obtain 7 minus 11, giving us 2 to the power negative 4. Now, 2 to the power negative 4 is equivalent to 1 over 2 to the power 4, which is, of course, 1 over 16. Thanks for watching my video. Please subscribe. Thank you very much.